This is the part where we start making our donuts look sexy. So we're going to be coloring our sprinkles, finally, so it doesn't look so depressing. And then also getting into rendering to start making this actually look pleasing with shadows and light and everything else. So first of all, the sprinkles. Now, as you probably know, you could come in here and you could select a sprinkle and then go, all right, I'm going to make a red sprinkle. And then I'm going to, don't do this by the way, I'm just showing you, make this aqua sprinkle and then a blue sprinkle, right? And this does work, does exactly what you would expect. The problem with this though, is that for one, the color is locked to that specific sprinkle. So this curved sprinkle is always red, okay? And the short sprinkle is always white. The other issue is that this is not easy to change the distribution of those colors. Like if I'm an artist and I'm looking at this, I'm like, that's kind of boring because all the colors is like 25% blue, 25% white, 25, you know. I want to have maybe 80% one dominant color and then a few splashes of complementary colors. I can't do that. So there is a much, much easier way. So first, let me just clear all of these and I'm going to create one new material. I'm going to call it sprinkles, and I'll actually show you how to quickly apply the same material to multiple objects at the same time, because we haven't done that yet. So I'm going to grab my round sprinkle, which is currently still over there by itself. I'll just bring it over here so it's part of the family. There we go. All right, so I've got one object with the material that I want to apply them all to. What I need to do is shift select all the objects that I want to have that material, and then lastly shift select again the object that has the material I want to apply them to, and you know that because it's highlighted yellow, okay? Then hit Control L. This brings up the link or transfer menu, and we want to link the materials. And now you can see our material has a 5 next to it because 5 objects are sharing this material. And that's it. And now obviously because they're linked, it means if I make a change over here, they're all going to be reflected. Great. Now we're going to do something fancy. So let's go to the shading tab, which gives us access to our nodes. Oh dear, where have I? All right, let's go back. I'm trying to get to that sprinkle. Okay, to our nodes. Now, I want to introduce you to a little friend called Shift-A, Input, the Object Info node. A very weird little node that just does some useful things when you might need it. So you see it pop up in a few tutorials. There's a bunch of stuff here that it can do. The most useful one for us in this instance is the random input. Drop that into your base color and let's see what happens. So we've got some gray values, and it's easier to see actually when you look at the donuts. So what this has done is it has assigned a value, a random value for each individual sprinkle between 0 and 1. So because that's then being transferred to color information, it means that, for example, this sprinkle might have got a value of like 0.023, right? And the robot spat that out. And then this one, this whitish looking one, maybe this was 0.89 or something like that. Okay, so it's just transferred those values into color information, which is just blacks to whites. Not very useful right now, but we can use that, those numbers in I'll just show you. Okay, Shift-A, we're gonna go Converter Color Ramp. Probably, I mean, I might have used this node more than any other node in Blender before. It's like so versatile, used for so many things. So drop it in here between the object info and the principled. And currently it is exactly the same because it's transferring that data into a gradient value of the exact same shades. But we can change this to any color that we want. And look at that. So you can very quickly see this is exactly how we're going to create sprinkles of different colors. Now, one thing you'll note looking at this is that every single sprinkle is a different shade. Like no two sprinkles have the same color right now because this is a gradient. And that's not how it works in the real world because the sprinkles come out of, you know, one constant icing bag, right? Or a machine with the same food dye. So basically all the blue ones would have the exact shade of blue and all the orange ones would have the exact shade of orange. So we need to change this from linear to constant. And now if I slide this across, look at that. We are influencing what percentage now is orange or blue. And this is really cool because it means you get to work like an artist and just create a really nice, appealing looking donut very, very quickly. So I'm going to go with like a light blue over here, and then I'm going to create a new color just by hitting the plus button. And then let's give this a purple like that. And I'll make this one pink actually, same shade as our donut, why not? You'll note, by the way, that I'm not going like full saturation, and that's deliberate because you learn in art that, yeah, like saturation and color is quite aggressive, it's quite noisy, and quite attention grabbing. And so if you use too much of it, it can be exhausting. So I tend to keep it at like 0.8. Okay, and then I'll also go over here and I'm gonna make this white. Let's go, oh, whoop, no, not like that. White, and I'm gonna create another one next to it, and this one I'm gonna make yellow. Okay, so just by sliding this around, I could say like less white, more yellow, less yellow, more white, and then I can go, yeah, more blue. It's just a really simple, easy way to create the exact look you're going for. Awesome. Now, something, you don't have to do this next part, but it's so easy. Why not? I was looking on Pinterest on like aesthetically pleasing donuts, like trying to make this look really cool. And I saw like metallic sprinkles, and I was like, that's an interesting idea. What if I made these white and yellow ones metallic, and then they would look silver and gold? So there is a slider in your principled BSDF, technical name that just means it's the shader that does everything. And it's the metallic shader. Look at that. So if I slide this all the way to 1, all my sprinkles are now metallic. And if I slide it all the way to 0, then they are non-metallic. And that's actually how you should use this slider. All materials in the real world are either non-metallic, also known as dielectric materials. So that would be most of the sprinkles. And then some objects are metallic, entirely metallic. There are technically a few rare materials on Earth that have some blend between it, but as a rule, you should not have a value that is between 0 and 1. It should be either 0 or 1. Anyways, so what we can do with this, because we've got this color ramp information here, is I can actually just convert, like I can make a color ramp that is just black and white that just shows which sprinkle is metallic and which one isn't. So, if I duplicate this, and here's a pro tip, if you use Control-Shift-D, it will duplicate it, but it will retain its connection. So it just saves you, I don't know, 1 second. And now I'm gonna connect that into my metallic input. Now currently this is wrong because this information is, it's just using, yeah, it's like color. So we need to be black and white. So this one here, because this is gonna represent my dielectric colors, I'm gonna set this to black, so it is non-metal. And then this I can delete, and this I can delete, because on the left-hand side of it, it's all black. Sorry, so it's all non-metals. And then over here, these two, the silver and the gold, they're gonna be metal, so actually I can delete the gold, and now that's doing exactly what it should. So we've now got dielectric, non-metals, and metals. And the reason it doesn't look like metal, by the way, is because your roughness is here. So if you set it all the way down, you can see it starts to look a lot closer to a metallic sprinkle. And by the way, you can get the exact like position. You can go like 0.7 and then here 0.7, type it in, and then that way it's definitely correct. For whatever reason of mine, this has to be a bug. There's something weird about it, but there's one sprinkle on my donuts, probably not on yours, but it's like, it's purple up here, but then it crept over into the metallic category down here, which shouldn't be possible, but evidently it's just on my donut. I've never seen it before, but one of them has actually snuck over. Doesn't matter. It's it can be the rare purple metallic one. All right, but I don't want these other ones to be shiny, at least that shiny. So I'm gonna again duplicate this, Control-Shift-D. And with this, if I plug this into my roughness input, just like before, these black and white values will decide what is the roughness of the metallic and non-metallics. So this one here, I want this to be essentially the opposite of what it is. Almost entirely black, a little bit, so there's a little bit of roughness to it, like that. And then this one over here, I want this to be a lot more diffuse. Not entirely diffuse, like somewhat of a blend, because if you look at reference, which you should be modeling off reference, there is some shininess to them. So yeah, but that is it. So you can see very quickly, we have created some very aesthetically pleasing donuts, and have fun with it, guys. Like create a cool looking donut. You can use whatever color combinations you want. I really do like it when people experiment and not just follow a tutorial down to a T, but like venture out there and, you know, do interesting things. So try different color combinations, try different icing colors, and you could make something that looks really cool. But that's almost it for our donut. It's pretty well done, which means we can now finally talk about rendering. So as a recap of part one, if you hit F12, that's going to put you into the rendered state. Our camera is really far away from the donut. So actually, let's first fix that. If you go to your camera view, you can just by clicking that little icon there, or by hitting number pad 0, that'll take you there as well. This is the camera view. We're really far away. I mentioned in the start that if you use this key, this button, view, lock, camera to view, that'll let you like grab it and move it around. But there is actually another way. I didn't want to introduce you to too many keyboard shortcuts at the start, but if you hit with the camera selected, Shift tilde key, that will put you in fly mode. The other way to do that, by the way, is to just go view, navigation, fly navigation there if you don't have that key. So anyway, in this mode, it's almost like you're playing a video game. So like I'm playing a first person shooter looking around my scene. W is move forward, just like in a video game. A is strafe left, D is strafe right, and S is back. So WASD, just like a video game. I can also go up by hitting E and then down by hitting Q. And if it's too sensitive, like if the movement is like, you know, crazy fast, the scroll wheel also decides how far, oh goodness, there it is, okay, how fast the movement is. So scroll down if it's going too quickly for you. But yeah, I can now place the camera wherever it is I want, and then when it's there, I just click, single left click, and that's there. And by the way, that mode is called fly navigation, and it works also not just from the camera view, but anywhere in Blender. If you ever want to just like, you know, move around, you can do use that fly mode. So Shift tilde key for that. All right, so we do a render, we get something that looks hideous. Why is that? Well, for starters, it's not a very the scene has just got one light in it. But the primary reason, and by the way, yes, that's the rendered view mode, but also if you go to rendered view shading up there, this is the exact replica of that, but just in the viewport, okay? Now, the primary reason this looks bad is because of the renderer, okay? So Blender's default render engine, if you go to your render properties, is called Eevee. Now, Eevee is fast, but it is not accurate. If you are familiar with games, most of you probably are, Eevee is basically a game engine. So it's designed to be really fast. Probably not 60 frames per second, but really, really fast. And it's in terms of the renderer types, there's usually actually, you call them like real time is what this type is, and that is a rasterized render engine. And then you have ray traced or path traced engines, sometimes called offline renderers, which are a lot more accurate but much slower. So this is good if you don't really care about realism. Like maybe you're making a title effect for a TV, you know, thing, whatever, or you're on a really tight deadline, you just want to get something out fast, you can use Eevee. Now you can make it look better than what we have. Like for example, I think because we're using like really small sizes for our donut, you want to increase your cube size and then your lamp, the bias, there you go. You set that all the way to 0, and now it's more appropriate for this size. We've got shadows, but it's still not great. We don't, for example, have shadows on any of our sprinkles because it's just too fine a detail. And the shadow itself, it's just like a blurry mess. So it's just a fakery, and it's just like what's going on with video games. I will briefly mention also that Blender 4.1, which is what this is here, it's in alpha state at the time of this recording. I've been using 4.0 for this whole recording, but this is 4.1, and it's Eevee, but it's completely rewritten, and it is better, right? So the shadows are better. There is actually even some bounce lighting happening, but it's kind of like a fake bounce lighting, and it's definitely better, but it's still not great. So that is the limitation. It's fast, but it is not great. And that's what you get with rasterized real-time engines. So there is another render engine. So go to your render engine settings and click the drop down. Ignore Workbench. That's for like just like basically rendering your viewport, really, for technical stuff. Cycles. So those are the two main engines of Blender. You got Cycles and you've got Eevee. Cycles is what's known as an offline renderer, or a path traced, also known as ray traced engine. Now, this looks way better than what we had before. You'll notice, for example, that all of our sprinkles have shadows. By the way, apologies if my recording gets a little choppy. It's because it's using the CPU to... Anyway, you can see it's got proper shadows on things. There's actually bounce lighting, right? That's like coming off this table here, and it's going underneath the donut. So it's like it's shooting around inside here, and it's shooting back, and it's going over here, which is exactly what happens in the real world. And it's really important for realism to get that bounce. I mean, any room, any architecture, you basically have to use cycles to do it, because that's how you get proper lighting like in the real world. But you get all this for free at the cost of speed. So you'll notice as I move around, whilst my recording goes choppy, that it starts grainy and then it kind of refines itself. And if you look in the top left-hand corner, you've got something that says samples. So as you leave it rendering longer, it's rendering more samples. Essentially, it's just like the computer's just chewing through it. There's technical ways to explain it, but that's the simplest way to think of it. And it'll get clearer as the longer you leave it. Now, there is actually two ways to calculate this. One is to use your CPU, which is what it's on by default. Another is to use your GPU, which is grayed out by default. So let's fix that. Go to Edit Preferences, and then go to System, and you can see at the top there, Cycles, Render Devices. So try switching to one of these tabs and see what you get. If you have a device, like myself, that is a GPU that is supported, then you can render on that and it'll be way faster. So just as an FYI, CUDA is NVIDIA, and it's for like cards, like I think 1080 backwards, so like 90s, 800s, I think they used CUDA. Optics was around the 2000 series further on. So Optics is the one that you use if you're using an NVIDIA card today. HIP is for AMD cards, and then you got one API. And I think actually on Apple devices, you'll have a metal option. But see what you have, and then see if you can render with that, because that, with GPU on now, it'll, going back to this, it might actually, the first time you use your GPU, it will say, I think at the top left-hand corner, doing this for the first time, it'll do some pass. It'll be really slow. It might take like 2 minutes, but then after you've done that, every time you open Blender, you should never need to do it again. So it might be slow the first time you activate it, but it should be faster. Now, this is way faster than what we had before. Like you can see how quickly it's clearing through those samples. It's basically real time. It's in fact, actually, so that noise that I mentioned, right? It's still there, but when you render and also in your viewport, you can use a denoiser. So it's actually not that new. It's like 3-4 years old. I think we started using AI denoisers. NVIDIA released their one for optics, and since then Intel have come out with one. And it basically takes that noisy image, it uses some of the information from the 3D renderer to clear it out whilst preserving the detail. So if you can actually turn it on in the viewport by hitting the denoise one. If you've got an NVIDIA card, it'll be way better. If you don't, it'll have to use the Intel denoiser, which is a lot slower. But you can see the noise is practically gone, right? So this is almost real time, which is really, really cool. Now, obviously, not all of you are as lucky, right? I've got 4 3090s. I started though on a Pentium 3, I think back in 2003. And I mean, look, they made Toy Story on computers that you couldn't even sell today because they would be just garbage. Maybe you could for like nostalgic. Anyways, the point is that everybody, when they start 3D, is using a device which is crappy. Don't let it limit you, or don't think, oh, I can't use 3D until I get a better computer. A graphics card is definitely one of the best investments you can make if you're thinking like, I want to do this as a career. This is definitely for me. I'm really enjoying this. It's definitely a good investment because you will be able to produce more renders throughout the day faster. but it is not essential. You can get by with just a CPU. It just means that when you do your render, your final render, instead of it being, done in an hour, you might have to leave it overnight. In the past, when I started with Blender, I was making crappy renders at like 600 by 400 resolution, and I was rendering for over a week just to do a really crappy basic animation. So don't let it hinder you. It's totally normal that you'll have a bad computer. If it's for you in the future, definitely worth investing in a card that is fast. Also, if you want to know which card to buy, Blender actually put together an open benchmark. So if you go to opendata.blender.org or click the link in the description, you can see it's showing you all of the people that have done this benchmark, what have their devices been and what are the times that you can expect. So you can see actually mine is at the bottom. It's the 3090, but I've got 4 of them. So it's obviously churning through it faster. The fastest is, basically it's going to be the top card or like the go-to. NVIDIA is just crushing it. I think, where is the AMD? They used to be on, I think AMD's made a mention there. You've also got CPUs on this side. But essentially, just buy the top like gaming card. Usually that's the one. But do go here, check it out if you want. All right, so we're going to be using cycles for the rest of this tutorial. And we'll really dive into it in the next part. But I just want to quickly, my lamp is way, way away. So let's just bring that in closer just so that we can see things. And you can actually clear the rotation of an object to make it appear at the center of your 3D scene by tapping Alt-G. Okay, so now, hey, look, that's actually kind of cool. I'm going to move my lamp over to here. Just check my recordings. Yeah, my recording's not being affected. And I'll just now reduce the strength of this because it's obviously now way closer. But look at that. Like, look at the shadow that we get coming off this donut. It's like properly tapered. It's not like some fakery, so it's like tight here and then it's like really faded at the end there. That kind of stuff is really difficult to do with a rasterized real-time engine like Eevee. And you also get like all of this proper, like look at the shadows on the sprinkles, the reflections is actually true. It's not like guessing and fakery. Yes, it's a type of fakery, but it's much more accurate. Anyways, I like cycles. I'm a cycles guy. I think most people actually are. The first version of Eevee was not that great. Eevee Next in 4.1 might be better. We'll see. But yeah, the first version of Eevee was not really that great. Now, one thing you might notice looking at your donut, they're going to make one big tweak to this, is that it kind of feels hard. Like the donut doesn't give this kind of like soft feeling to it. And the reason for that is the material. So by default, all materials are, kind of like hard materials, but fleshy objects like humans as well as food have subsurface scattering. So I'll throw some reference photos here. But you can see this is my hand. I had light coming in like as I was eating breakfast, and I could see the light is actually going through my fingers, right? So that's light that is it's a mushy, fleshy object, so it's passing through it, scattering amongst all the other atoms in the finger, and it's the light is going through to the other side. You also see it in a lot of food. So took these photos at a party. Yes, I am that guy. But you can see that's how you get light that goes to the opposite sides. My daughter was eating a banana, and I was like, look at that banana. Look at that subsurface scattering right there. So donuts and icing have that, and we can do that. We can add that, by going to the materials, and then down here you've got subsurface. Okay, so here, the biggest one to turn it on, and just like metallic, apparently, this is, by the way, a new setup for 4.0, but just like metallic, it's supposed to be a weight of either 0 or 1. All right, now when you do 1, it suddenly turned blue, and you're like, what the hell happened there? That's because the radius, this radius, is this is your X, Y, Z, but also it's your R, G, and your B in this case. And these values are different because it's designed for skin by default. So this is a great setup if you've got skin with blood inside, but we don't. So click, drag down, and then just set these values to 1. All right, so now it's closer to the material. Still looks weird, and that's because the scale of this is wrong. It's saying that the thickness of the object is 5 centimeters, but this icing is not that. So let's make this 0.01, and now you can see it looks a lot closer. It's still a little dark, because I think it's not 1 centimeter thick, so let's go 0.005. And now we can see it's pretty close to its original material. The biggest difference is if I just zoom right in here, let's set it to what it was before. See how it's hard? It almost feels like, it just feels like concrete, right? But then you set this to 1, and look at that. The shadow just starts to feel a little softer, and you get this bleed effect where kind of like the shadow gets like an edge to the shadow where it gets a little more saturated and pinker. And that's subsurface scattering. You don't have to tell it how to do that. It just does it. So you set the weight to 1, these to 1, and then you just set your scale to whatever it is you want. And I'm also going to do it for my sprinkles. So I'm just going to click on one of my sprinkles, and yeah, right in here for the subsurface, I'll just do the same thing. Set the weight as 1, these radiuses to 1, and then I'll use a really low value here. Like let's go 0.02. And now you can see, because these sprinkles are, yeah, it's like icing, right? It's just the exact same thing. Yeah, we want some of the light to pass through it. And we don't actually have to bother setting up that, that color ramp system for the metal, because metals, automatically that shader, when you set it to 1, it means it's going to cancel any subsurface scattering that would have appeared there. So we don't have to bother with it. The subsurface is not going to happen on metals. But you can see it starts to feel a lot softer, a lot, I don't know, more pleasing, more delicious looking, like real food, because that's really one of the telltale signs of food is subsurface scattering. Awesome. So in the next part, we're going to start really building out the scene. What I want to do though, at the end of this video, I want to give you some homework, and that is to try to model this plate. Now we're going to do it actually in the next part, but it's simple enough, and it's actually possible to use all the tools that I've mentioned in this, this series so far to model this yourself. Now the reason I'm trying to give this as homework is that once this tutorial finishes, that's how it's going to be. You're going to have to try to solve problems on the fly. So it definitely helps solidify learning if you can try to apply it by yourself. So have a go. It doesn't matter if you get stuck or you fail at it terribly, because you can just click the next part and see how it's done. But have a go at it now, because then you'll start to, you'll just retain the information a lot better. Anyways, go ahead, click here and see how we build the rest of the scene and build that plate.